Hello, it's dumplet here. Here's an item on trigonometry. Take a look at the figure on the left. The blue segment AD is an angle bisector of angle BAC. Find the area of triangle ABC. This item came from DAM 2022, an examination that Dumplet has hosted. The link to the PDF file will be in the description. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Now, we do have an angle bisector, so I think it would be enough for us to chase the angles. So if you chase the angles, just to make use of just some basic knowledge about triangles. Okay, now let's do some angle chasing here. So obviously the 60-degree angle, it's bisected, so we should have two 30 degrees angle over here. Now I'm not gonna put the degree symbol, it's a little bit redundant, I guess, so I'm just gonna put just 30 here. Now the next thing to observe is that, well, AB and AD, they are the same. Okay, so triangle ABD is isosceles. So these two green angles over here, angle ABD and ADB, they should add up to 150. So divide that by 2, so that's 75. So these two angles must be 75. And we could just finish the rest of the things here because, well, this angle is just the supplement of 75, so that must be 105. And then this angle over here, well, you can just do 30 plus 105 plus this angle x, that should be 180. We should be able to find that this x must be 45. So I'm just going to put 45 here. Okay, now next, let's talk about how do we get the area of the triangle. Now we could get by Heron's formula, which is a little bit difficult in my opinion because we don't have AC and BC yet, but we do have angles instead. So, well, we do have a nice 60-degree angle here. So one might recall the nice formula for the area, 1/2 AB times sine theta. Now, we just need two side lengths, AB, and the angle between them. Now, in this case, I think our goal is to try to get what AC is. I'm just call this X, but to try to get what AC is, because, well, I could essentially just make this 3 to be the A, this X to be the B, and then my theta over here, I'm just going to make it at 60 degrees, and I could use this nice formula for the area of the triangle. So my goal is to get X, and we do observe that we do have complete set of angles, and these angles are relatively okay, and we just have 3 and X here, so that kind of motivates us to use the sine law, right? The law of sines. Now, just remember that for the sine law or the law of sines, it's just forming an equation in terms of the side divided by the sine of the angle opposite to it. All right. Now, in particular, we're focusing on triangle ADC here. Okay. Now, as mentioned a while ago, I'll just make AC to be X. All right. Now, since I want to get X, I should incorporate X into the equation that I will be forming. So let's just say the side is X. The angle opposite X is this 105. Right, so sine of the opposite angle, 105 degrees, right? And that should be equal to, we just need another one. Now, conveniently, we have the 3. So 3 divided by sine of the angle opposite, the 3 is the 45 degrees, okay? Now, sine 105 and sine 45, they are pretty nice values. Sine 105, that's equal to the square root of 6 plus the square root of 2 divided by 4. And then sine 45 over here, that's just the square root of 2 over 2. Okay, now we could solve for x here. So let's multiply both sides by the square root of 6 plus square root of 2 divided by 4. So we should be able to get that x will be equal to, 3 divided by the square root 2 divided by 2. That's for the 3 over sine 45. Now just write this as times 2 like this, and then the sine 105, that was square root of 6 plus square root 2 all over 4. Okay, we can do some cancellations. The 2 and the 4 cancels nicely, and the square root of 2 over here cancels with the square root 6 plus square root of 2 over here nicely. We do have square root of 3 plus 1 here. So x here would have to be 3 times my square root of 3 plus 1 in the numerator, and in the denominator we just have the 2, right? So x would be 3 square root 3 plus 3 divided by 2, okay? So not the prettiest value for x, but at least it is an exact value, and it's actually not that bad. Okay, moving on, now that we have x to be that, it's just literally applying the formula, right? So the area of the triangle should be equal to, as mentioned a while ago, I'll just let this to be the A, let this to be the B, and I'll make this 60 degree my angle theta, the angle between two sides. Okay, so 1/2, so 1/2 times 3 times my 3 plus 3 square root 3 over 2, and then times my sine of 60 degrees, right? And all I have to do is just evaluate this one. Okay, now sine of 60 degrees, it is just one of those special angles. That's going to be equal to square root of 3 over 2. And then let me just copy the rest. So 1/2 times 3 times 3 plus 3 square root 3 divided by 2. Working on the denominator first, I just have the 2's. So in the denominator, I'll just have simply 2 cubed, so that's 8. And then in the numerator, essentially, I'll just do 3 times the square root of 3 first. So 3 square root 3 times my 3 plus 3 square root 3. And just work on this at the end. So 3 square root of 3 times 3, that's going to give me 9 square root 3. And then 3 square root 3 times 3 square root of 3, that's going to give me 27, right? So the area of the triangle would have to be 9 square root of 3 plus 27 all over 8, right? And this is our final answer. Hopefully you guys learned something new for this video, and I'll see you in the next one. Bye-bye!